Hey guys, welcome back. Today I'm just going to focus on formally justifying L'Hopital's rule in case of a free response question, and we're going to do that using a couple of graphing problems. Okay, so remember when to use L'Hopital's rule. Make sure it's a case of indeterminate form before you apply it. And here we go. Okay, so if you just plug in the 3 in your head, you can see whether L'Hopital's rule applies, but how you write it for a free response question is very, very specific. So you might just informally plug in the 3 right now to figure out if this is 0 over 0 or infinity over infinity. But if you simply say this on the AP exam, that's not going to be good enough. So let me show you how you have to write that. You have to write this limit separately in the numerator and the denominator while you still have x's. So I'm going to write the limit as x approaches 3 of my numerator over the limit as x approaches 3 of the denominator. Now, when you replace those x's with 3, then you can get rid of the limit symbol. But you have to start with that statement right there. Okay? Now I'm going to replace the x's with 3, and then I don't have to write the 3 anymore. I'm sorry, I have to write the 3. I don't have to write the limit anymore. Okay, and I don't have to even show 3 squared minus 9 is 0. I can just write 0, but I'll write it for your benefit. Okay, now we got to evaluate that. Well, obviously on the denominator, 3 squared minus 9, that's 0. In the numerator, let's find h prime of 3. Well, pay attention to the title of your graph. This graph is h prime. So h prime of 3 is just the height at 3, which would be the height right there. Oops, I kind of missed it, but you get the idea. So that looks like a 2. So 2 times 2 would be 4. 4 minus 4 is 0. Oops. And you do have to write that also. So the steps that you have to show, you have to write this to get credit on the AP exam and this in order to show that L'Hopital's rule then applies. Once you've written that, now you can say, okay, apply L'Hopital. So now let's do that part. Applying L'Hopital means do the derivative of the top and the derivative of the bottom separately. Let me make some space. Okay, so the derivative of the top would be derivative of a derivative is second derivative. And on the bottom, the derivative of x squared would be 2x. And the derivative of those constants is 0. Okay? And now I have to write that limit symbol again, okay, for both of them. So I have to squeeze that in there. Now, when I replace those x's with 3, then I get rid of the limit symbol. So this would be 2h double prime of 3 and 2 times 3, which is 6. Okay, now let's go figure that out on the graph. H double prime of 3, second derivative. Well, if this is a first derivative graph, then the second derivative is the slope at 3. So at 3, what is the slope here? Pick any 2 points that are convenient. I'll use that point and the end point. And count your squares. I can see it's a rise of 2 and a run of 3, so that's 2/3. So I have 2 times 2/3 over 6, which would be 4/3 times 1/6. Cross cancel if you want to. Honestly, on the AP exam, if it's free response, you don't even have to reduce your fractions. Final answer, 2/9. Okay, so focus on how to justify this time, not just getting the right answer, but how do you get credit for it? Because if this is a 3-point question, and it often is, then they're going to divvy up those points with all those formalities, okay? Why don't you try this one on your own, justify formally, hit pause, and do this one on your own. Okay, first, did you write the limit and leave the x's in the problem? If so, good job. 1 point, hopefully. Next, you can get rid of the limit symbol when you replace the x's with -1, but you honestly don't have to write that step. Okay, now we have to evaluate it. G prime of -1 If this graph is a graph of G prime, then I want the height at -1, which is right there, 2. So we get 2 minus 2, which is 0 over 0, and you do have to write the 0 over 0. Okay, so you had to write this, that's probably a point. You have to write this, that's probably a point. Okay, and now we can state L'Hopital's rule applies. So you'd write apply L'Hopital. And now we'll do the derivative of the top and the derivative of the bottom. Okay, did you write the limit again? Derivative of the top and the derivative of the bottom. Next, replace those x's with -1s. Okay, and now evaluate the second derivative at -1. If that's a second derivative question, but this is a first derivative graph, then we're looking at the slope at -1. And the slope at -1 appears to be down 2 and over 1, so -2. So all of this is equal to -2 over -2, so my final answer would be 1. Okay, nothing new really today, just a little bit more focusing on formal justifications if you have to do that on a free response question. So today you're just going to do the even problems of the same worksheet that you did yesterday, okay? And yesterday, there were a couple questions on the worksheet yesterday. If you didn't remember how to do perhaps the derivative of inverse sine, just look it up. You do have to know it, but you can look it up. And also maybe, I think it was number 5 that had the derivative of like 2 to the x. So you have to look those up. Those were a little tricky. Maybe didn't quite remember those. That's normal. Good luck, guys. Hope you're doing well. Bye.